Well, now I will present two cases in which a peak of sea level has been partially related with Risaga, with METEO tsunamis in the Balearics. The two cases I will review is one in January 2020, and the other also January of 2030. Note that January is a season in which the frequency of METEO tsunamis is lower, is low, is small in the Balearics. But in these cases, something have occurred. This is in the upper part. We have the complete register of the sea level in the SOCIP station of Porto Cristo during the first event, that is the event of January 2020, that is related with the presence of a very intense and important cyclone in the Western Mediterranean. From this total register, we can see that the peaks that are observed in Porto Cristo are above 65 centimeters above the average of the level some days ago. It's even more clear, this distribution, if we use detailed signal as in the lower part. Well, this important peak have occurred in this place, that is Porto Cristo. Here you have the complete geography of the area. It's important to note that here is Porto Cristo, and here, by this zone, there is the Mount Boy, in which the waves are continuously recorded. This is a higher resolution picture of the zone, showing that the entrance, the inlet of Porto Cristo is quite narrow, quite long also. And then in this geographical frame, this is the synoptical frame. Here there are maps of wind. The color corresponds to wind, and the lines correspond to isobars. We can see that from 19 to 71 of January, the strong winds are always present, but the minimum of pressure in the Balearics is not occurring at the moment of the maximum peaks of sea level, but in other moments. On 19 at 12, we have the minimum pressure at the Balearics, but at the 21 and at 12 is the maximum wind speed in the region. Well, this storm, this important storm, that had produced very strong winds, it was called Gloria, Borrasca Gloria, Cyclone Gloria in the Western Mediterranean. Well, about this event, the METEO has produced a simulation of the wind speed, of the sea level elevation, and of the wave heights. We can note here that the elevation of the sea level. ¿Eso no funciona? No. Bueno, es igual.
Has de posar que no es comparteix la pantalla. Aquí dalt.
Aquí.
Sí. Pitja. Aquí, duplicar presentación.
Ah.
Y aquí sí que et deixa.
Bueno. Sí. No, tampoc. És igual. Well, look, we cannot see this, the evolution. Ara què ha passat? Va, socorro. Well, looking to at the sea level evolution at the same time as the pressure, the atmospheric pressure evolution, we can see that the mean elevation that can be named the storm surge associated to the presence of this storm is during this period with the maximum height around 21st and midday. That is not the moment in which the pressure is minimum. When the pressure is minimum, there is also a peak of sea level, but it's not the maximum. The maximum is later when the waves are the largest. This is the wave registered in the buoy of Mahon, and we can see that in this case we have this peak of very high wave height. The maximum the maximum wave height has produced here in Menorca, in the Bay of Menorca, with more than 14 meters of elevation. This is an absolute record of height waves in the Balearics. Well, looking at other details, this is the original register, but filtered to have only the high frequency signal. What can see? We can see that the maximum oscillations in high frequency are coincident with high frequency oscillations in the atmospheric pressure. Looking at the satellite image, we can see that the flow towards the Balearics, here is Mallorca, here is Porto Cristo, shows very clear train of gravity waves coming to the zone and producing these two effects: the large scale, the high frequency pressure oscillation and the high frequency sea level oscillations. The system briefs of the SOCIP has tried to reproduce this situation and have shown that the METEO tsunamis associated to this moment of the evolution is quite well reproduced. Here we have together the observation and the brief forecast, and here also the same, the observations and the frequency of analysis here. Well, then in that case we have peaks that are 25, 30 centimeters that can explain the presence of metatsunamis, but 30 centimeters more are provided by the storm surge, and this can give the total around 65 centimeters that are observed. Well, looking at the other case is a case less documented because there is no register that time in the case in Ciutadella, because the event is affecting Ciutadella, but we have as alternative the newspaper information, and in the newspaper you can see here. That the area, the port of Ciutadella, the docks of the port of Ciutadella were flooded by what? In the local press, it was commented that this was a surprising risaga because was not foreseen so large risaga in that case. But when we look to the synoptic situation, what we have here is the presence again of a strong depression, of a deep depression with pressure of around I don't remember, but less than 990. It's around 985 hectopascals. That is a quite low pressure here. Then we have this perturbation that can produce storm surge. And looking at the winds, there are strong winds across the Balearics. Looking at the Palma and Ciutadella, we can see that both locations are open to the southwestern winds, and that are the winds blowing in with this kind of cyclone. We don't have information about Ciutadella, but looking at the Palma tide gauge, we can see very clearly the storm surge with an elevation that is more than 30 centimeters. Is an important elevation that, if it's added to a even weak or moderate risaga, can produce the problem of flooding in Ciutadella. To know if there is possibility of meteor tsunami combining with this storm surge, again, SOCIP has produced a hindcast of the situation to see what the brief system was able to say about the possibility of risaga, the possibility of meteor tsunami in this case. The model, the system, has produced a fall in the general pressure, and also some oscillation of the sea level pressure. But looking at this map in which the maximum amplitude of the pressure oscillation is put, I can say that in Ciutadella we have high amplitude of pressure oscillations, but not in the channel. Then the amplification by problem resonance is really difficult. And in fact, this produces that the model, the brief system, is giving a really weak oscillation, really weak meteor saga. But the ambience is favorable. Then we can conclude for this case that the brief system is doing meteorologic likely situations, but the perturbations are not perfectly situated in a good place and with better distributions. But some meteor tsunami, some oscillations related to meteor tsunami do exist probably, and that what is sure is that they had combined with the storm surge, and that produced this peak important in that case. Thank you very much.
Yes.
I missed what is the characteristic period of oscillation produced by this internal waves?
But in the internal point in Ciutadella, we don't have information for this case because the system of force layers Balears was out of.
But you have this observation you showed beautiful pictures. So what you could estimate what periods this internal
The atmospheric waves. Yeah. Well, I had not measured it exactly, but it's similar to the frequency of the meteor tsunamis in Puerto Cristo. That is around 5 minutes or so. The gravity waves are quite small. We can see here. Look at this.
Absolutely beautiful picture.
Yeah, the long wave of the gravity waves, or the internal gravity waves, is less than 10 kilometers, because the distance for is between Palma and Alcudia are 50 kilometers. Look at this. We have wavelengths around 10 or less than 10 kilometers, and that could correspond to frequencies of around 5 minutes, perhaps a little more, but that are compatible with resonance in the port of Puerto Cristo. I think so.
Yeah, what I would like to say that wave models are not able to cope with such fast oscillations, so of wind velocity and so. So you cannot trust a wave model in these conditions.
Yeah.
Any further questions? Yeah, Piero?
Possibly, I apologize, a naive question, but if waves were generated in northern Africa and they propagated across the Mediterranean Sea to the Balearics, why were they detected just in
Well,
one place?
Well, in this case, it seems that the waves are coming from in Africa, but this is not the most frequent, the most frequent case in the Balearics. In most of the cases in the Balearics, the gravity waves are appearing over the sea. Then we cannot say that the mountains in northern Africa are forcing the gravity waves. We cannot not say that, but because if in this case this looks possible, in other case, in many other cases in which Risaga occurred in Ciutadella, the waves have appeared in around this area, or around the area between the Balearics and the African area, over the sea. Then without possibility of influence of the mountains, except one, that the mountains in northern Africa are supposing that when African air is entering in the Mediterranean, this African air is entering at a height, not at sea surface, but a height that is around 1,500 meters. And then this produces a thermal inversion in the area of the Balearics, because the warmest air is above, where the African air is entering, and the bottom air is Mediterranean air that is, well, not colder, but less warm than the above. Then the presence of this inversion can produce that the internal gravity waves produced over the sea, even in high levels, when extended to the inversion layer, can produce an enhanced oscillation of the sea level pressure due to the contrast between warm and cold columns in the oscillation. Then, in the case, it looks like the effect is orographic, but I can suppose that is not. Look at this picture with more detail. Here in this zone, we have an area of a color very different of this one. This is detecting, this is showing the presence of dust from the desert. Then confirmed that the effect, the presence of a thermal inversion can be guaranteed in this case. Sorry, too large.
No, that's okay. Thank you, Agustin. So, well, quick. Yeah, go ahead. Quick.
If I keep a bit, how critical is the area where the waves are triggered for the place where they are detected? Because if I have association with standard tsunamis, okay, earthquake-generated tsunamis, of course you have focusing in some very precise spots because of bottom topography, but generally the area that is affected has some extension. Why my impression it is that for this sort of METEO tsunamis you can have a very localized impact, and you move a bit far apart, and you even in the accurate measurement you don't get it. Is that the case?
Well, the formation of gravity waves is critical, but the place where they form depends of the upper area, the synoptic pattern, and particularly the presence of strong southwesterly winds over the Balearics. Because if the gravity waves are formed in such a way these waves can propagate above the Ciutadella area, we will have METEO tsunamis in Ciutadella. If not, it is not possible. In this case, In this case, the area of formation is not the most typical, and what we see is that the gravity waves in the case are moving towards the eastern part of Mallorca, but not directly towards Ciutadella. The Ciutadella is less affected in that case. And in fact, looking at data, in this case, the oscillations in the METEO tsunami in Ciutadella was less intense than in Porto Cristo. And this could be related to the position of the area of generation of the METEO, of the gravity waves. Then, in this sense, the place of formation of the gravity waves is critical, but combine it with the upper air synoptic pattern.